Hello students, in this video we'll see a Gaussian elimination method to find out the solution for a given set of linear equations that you see, okay, where to determine the solution of this particular linear equation now we apply Gaussian elimination method. So Gaussian elimination method is sometimes called as back substitution method. We call it as back substitution method. So we'll see what is back substitution method by having this example what we can see. So let us go with this example. So again, for Gaussian elimination method, what we do is we write the augmented matrix for this particular equation. So therefore we'll try to write in this way. So I think in the same way we even write for Gaussian Jordan elimination method, augmented matrix, we call it as augmented matrix that we write, augmented matrix. So where this is nothing but AX equals B form, okay. So this is AX equals B form, and for that we write an augmented matrix in this way: minus 1, 1, minus 1, 3, minus 2, minus 2, and we'll put a slash here, and then we'll write the right hand values here: 14, minus 1, 5. So now what we do is we'll try to apply row operations in this, and we'll try to solve the given matrix by applying row operations, and we reduce the matrix into an echelon form, and then we see how to apply this back substitution method to find out the solution. Okay, so for that let us go step by step. So first we write row 2 equals, we'll do the operation on row 2, would be equal to row 2 would be equal to row 3 minus 3 by 2 times row 1, 3 by 2 times row 1. Row 2 equals row 3 minus 3 by 2 times row 1. Okay, so that is what we do now. So we'll do that: 2 minus 1, 3, where row 1 will remain as it is. Now 3, so here 3 minus 3 by 2 into 2, which is 3 minus 3, which is 0 here. And now 1 minus of minus plus 3 by 2 into 1, so you get 2 plus 3, 5 by 2, you get 5 by 2 here, this is 5 by 2. Then you have minus 2 minus 3 by 2 into 3, so which is minus 2 minus 9 by 2, so minus 4 minus 9 will be minus 13 by 2, you get minus 13 by 2, so this is 14. Now minus 1 minus 3 by 2 into 14, so this is 2 7s are 14, so minus 1 minus 21, which is minus 22, you get minus 22, and this I'll write 5 minus 1 minus 2 5. So this is what we get. Okay, so first one is 3 minus 3 by 2 into 2 gets cancelled, 3 minus 3 is 0. Second one is 1 minus of minus plus 3 by 2 into 1, which is 1 plus 3 by 2. So if you take LCM, 2 plus 3 is 5 by 2 you get. Then so third one is minus 2 minus 3 by 2 into 3. So you get minus 2 minus 9 by 2. So 2 into 2, 4, minus 4 minus 9, minus 13 by 2 you get. And the right hand side you have minus 1 minus 3 by 2 into 14. So 2 7s are 14, so minus 1 minus 7 into 3 is 21. So minus 1 minus 21 is minus 22. Okay, now I should see through that so this is first operation. Now I should make this 0. So therefore row 3 equals row 3 minus 5 by 2 times row 1. That is what I'll do here. Row 3 equals row 3 minus 5 by 2 into row 1. So let us see what will happen. So I get this to be 2 minus 1 3 0 5 by 2 minus 13 by 2. So here 5 minus 5 by 2 into 2, so 2 gets cancelled, so this becomes 0. Then minus 1 minus of minus 1 plus 5 by 2 into 1. So 2 ones are 2, 5 minus 1 is 3 by 2. So you get 3 by 2. Then minus 2 minus 5 by 2 times 3. Okay. So 5 3s are 15. 2 2s are 4. Minus 4 minus 15 is minus 19 by 2. So this I get minus 19 by 2. Then right hand side will be 14 minus 22. So here 5 minus 5 by 2 times 14. So 2 7s are 14. 7 5s are 35. Therefore 5 minus 35 will be minus 30. So this is the matrix that we get after doing the second row operation. Okay. Now what else we can do? That is what we need to think here. So I'll just multiply the first, second row and third row with the 2, so that we'll see what will happen. So I can say it as 2 minus 1 3. So I'll just multiply R2 with 2 times R2, R3 with 2 times R3. So what will I get? So 0, 5 by 2 into 2 is 5, minus 13 by 2 into 2 is minus 13. 0, 3 by 2 into 3 is 3, minus 19 by 2 into 2 is minus 19. And similarly left hand side what happens, right hand side, sorry, 14 minus 22 into 2 is minus 44, minus 30 into 2 is minus 60. So this is what we get. Okay, so this is the matrix that we have got. Now what should we do? Now further I should see through that this becomes 0. This should become 0. So for that, if I go with row 3 and row 1, then this 0 will get vanished. So therefore what should I do here is, I will see that row 3 will be equal to row 3 minus 3 by 5 times row 2. 3 by 5 times row 2. This can happen. Okay, row 3 minus 3 by 5 times sorry. Yeah, so it is 3 minus 3 by 5 into 5. So 5 5. Okay, yeah. So therefore what will I get? I'll be getting 2 minus 1 3 0 5 minus 13. So 0 minus anything into 0 is 0. 3 minus 5 by 3, 3 minus 3 by 5 into 5 is again 0. Then minus 19 minus 3 by 5 into 13. So it is plus 3 by 5 into 13. So here what will happen? So 19 by 5. So let me do that in the calculator. So 19 into 5 is what we need to do. 19 into 5 will be 95. So here minus 95 plus 13 into 3. 13 into 3 which is equal to 39. 39 by whole thing by 5. So what do I get? 39 minus 95 would be equal to minus 56 by 5. I get minus 56 by 5. So anyway, minus 56 by 5. So in the right hand side what it will happen here is, so this is 14, this is minus 44, so this is minus 60 and minus of minus plus 3 by 5 into 44. Okay, 3 by 5 into 44. So what will I get? So here 60 into 5 would be equal to 300. It is minus 300 plus 44 into 3. 44 into 3 is 132. 132 by 5. So if I say minus 300 plus 132 is minus 168 by 5. I get minus 168 by 5. Or this is the final row that we have got after the row operation. Now what I'll do, we'll make row 3, we'll try to take row 3 to be divided by, to be multiplied by 5, sorry. Let us take row 3 multiplied by 5. So 5 times row 3 if I do, the final matrix that I get in Gaussian elimination is this. So I got 2, 3, 0, 5, minus 13, 0, 0, minus 56, and then I have 14, minus 44 and minus 168. Now this is the final matrix in Gaussian elimination method. So here we try to make these 3 elements 0 in 3 cross 3 matrix, and then we try to do back substitution method. So what is that back substitution here is, the last one what you have got is nothing but minus 56 times, it is what? It is x3. If you see, the last element is nothing but x3. Okay, so minus 50 times x3, 56 times x3 will be equal to minus 168. Keep that in mind. Minus 56 times x3, because other two are 0 here. x1 and x2 are 0. Therefore, minus 56 times x3 equals minus 168. Therefore, 56 times x3 will be equal to 168. x3 will be equal to 168 by 56. Now, if you do that, you will be getting x3 to be equal to 3. So, this is the solution, one solution, which is x3. Now, we are going to write the second equation by looking into the second row. What is that? 5 times x2, because x1 is 0 here. 5 times x2 minus 13 times x3 equals minus 44. So here x3 is 3, therefore 5 times x2. So that is what back substitution. You find out x3 first and then substitute to x2 and then find out x1. That is what back substitution method. So minus 13 times 3 equals minus 44. Therefore 5 times x2 equals minus 44 plus 39, because 13 into 3 is 39. Therefore 5 times x2 equals minus 5. Minus 44 plus 9 is minus 5. Finally, we get x2 to be equal to minus 1. x2 to be equal to minus 1. This is the second solution. Now finally you write the equation in terms of first row, which is 2 times x1 minus x2 plus 3 times x3 equals 14. Now you substitute x1 and x2, x2 and x3 value in this equation. So what do I get? 2 times x1 minus of minus 1 is x2 plus 3 into 3 is x3 equals 14. So therefore 2 times x1 equals 14. Minus of minus 1 is plus 1. When it comes to the right hand side it becomes minus 1. 3 into 3 is 9. When it comes to the left hand side, right hand side, it becomes minus 9. So therefore 2x1 is equal to 14 minus 10, which is equal to 4. Therefore x1 is equal to 2 into 2, which is 4. So these are the 3 different solutions that we have got by Gaussian elimination method. Now to verify these 3 values, what you can do is, you can use your calculator and choose 3 unknowns in your calculator and try to type these equations in your calculator and find out the solution. Definitely you will get a solution minus 1, 2 and 3 for this particular 3 equations. You can do that in your calculator. I hope you know that. You need to go to the mode button. In mode button you need to choose 3 unknowns, simultaneous equations. In that 3 unknowns you should type, and then in that 3 unknowns it will ask you to type the coefficients of all these 3 equations. Once you type all the coefficients and then finally press equals, 3 times if you press equals, you will see that 3 different roots it will show, and that 3 roots is nothing but the solution that we have got here in the Gaussian elimination method. Okay, so let us go with the next example. So these are the three roots for the first problem. So let us go to the next problem. Okay, so these are the equations of the second problem. Okay, so now we'll again use Gaussian elimination method. So we'll use Gaussian elimination method to find out the solution for this particular problem. Gaussian elimination method to find out the solution of this particular problem. So the first step is we'll write the augmented matrix for this particular equations. So the augmented matrix is which is very important to write first. So therefore it is 1 1 minus 2 1 0 0 1, because x is not there. So therefore 0 1 1 minus 2, then second is 1 2 minus 1 0, third is 2 4 1 and minus 3, fourth one is 1 minus 4 minus 7 minus 1, and therefore in the right hand side you get minus 3 2 minus 2 minus 19. So this is what, close the bracket here. So here now we need to do the row operations to find out the solution. So let us do the row operations for this. So what we do, first thing, before row operations we'll interchange the second and first row. That can be done. So interchange, because 0 is on top, so we'll interchange. So interchange row 2 and row 1. So what we will get, so we'll get 1 2 minus 1 and 0 on top, and then here 0 1 1 minus 2 on bottom. So here 2 4 1 and minus 3, then 1 minus 4 minus 7 minus 1. Then what we do is we'll write 2 on the top, minus 3 on the bottom, because we have exchanged it, minus 2 minus 19. So close the bracket. Okay, now we have to perform the row operation here. So what we do is very simple. So we need to make this one and this whole thing, this complete terms should become 0. So we'll see that now line by line. So I'll take row 4, I'll try to make row 4 to be equal to row so not row 4, so I'll just play with row 3 first. So row 3 equals, so I'll take row 3 equals row 3 minus 2 times row 1. So let me do that. So what will I get? I'll get 1 2 minus 1 0 0 1 1 minus 2. So here 2 minus 2 into 1 2, so 0. It is 4 minus 2 into 2 is 4, again this is 0. Then 1 minus of minus, so 1 plus 2, which is 3. So it is 1 minus 2 into minus 1, so 1 plus 2 is 3. Then we have minus 3 minus 0, so it remains to be minus 3. And this is 1 minus 4 minus 7 minus 1, I'll write as it is. And then I'll have 2 minus 3. So here minus 2 minus 2 into 2. So minus 2 minus 4 is minus 6. And this is minus 19. So the next step what I can do is I can divide, I'll just write it here only, row 3 with row 3 by 3. If I divide that, what happens here is this becomes 1, this becomes minus 1. So this becomes 1 and minus 1, and this becomes 2. This becomes minus 2. Okay, so this is possible. Okay, now what is the next step? The next step is I'll try to go play with row 4 now. So row 4 would be equal to row 4 minus row 1. So what will I get? So I'll get 1 2 minus 1 0 and 0, 1, 1, minus 2, 0, 0, 1, minus 1. So here 1 minus 1 is 0, minus 4, minus 2, which is minus 6, and then minus 7 plus 1 is again minus 6, minus 1, minus 0, so minus 1, and this will be 2, minus 3, minus 2, minus 19, minus 2, which is minus 21. Okay. So the next step what we do is, we'll try to take row 4. You cannot divide by 6 and all because I have 1 here, so I cannot divide it. So I'll take row 4 and then I'll say row 4 plus 6 times row 2. I'll say row 4 plus 6 times row 2. Okay, so that will end up in getting the final matrix, I hope. So let me do that. 1, 2, minus 1, 0, 0, 1, 1, minus 2. This is 0, 0, 1, minus 1. Then 0 plus 6 into 0 is 0. Minus 6 plus 6 into 1. Minus 6 plus 6 is 0. Minus 6 plus 6 into 1, again 0. Minus 1 minus 6 into 2, 12. So minus 1 minus 12 is minus 13. So put a block here. So it is 2 minus 3 minus 2. So here minus 21 plus 12. So minus 21 plus 12. So what do we get? So you get 11 minus 2, which is 9. 9 and yeah, so 9 is what the answer. So you get 9 here. So you get 9. So it is minus 21 plus 6 into, oh sorry, 6 into 3. I think we should do it with the second row. Sorry. So it is minus 21 minus 6 3s are 18. So you get minus 39. Minus 39. Okay. Now I think the last row, if you see, I can easily divide the last R4 with R4 by 13, because 13 into 3 is 39, right? So therefore what will I get? This minus 39 and this minus 9 will get changed. So minus 13 will become minus 1, minus 39 will become minus 3. So this is the end. This is the end for the Gaussian elimination. Further you need not to do anything, because in Gaussian elimination the elements below the principal diagonal elements should all become 0. This all becomes should 0. That is what that is where it helps in back substitution, because now I can easily write minus w equals minus 3. So therefore I got w to be equal to 3, right? W to be equal to 3. Then the second row, if I write, it is xy 0, so z minus w equals minus 2. See here, x, y, z's are 0, so it is minus w equals minus 3, so w equals 3. So z minus w equals minus 2 in the second row, therefore w is equal to 3, therefore z minus 3 equals minus 2, therefore z equals 3 minus 2, therefore I got second solution z to be equal to 1. The third solution is in the second row, it is y, so I can write the equation. So it is y plus z minus 2 times w equals minus 3. Y plus z minus 2 times w equals minus 3. Now I got 1, so I will substitute for z. Then I got 3 for w, so I will substitute w as 3. So 3 into 2 is 6 equals minus 3. Therefore y equals minus 3 plus 6 minus 1. So therefore y to be equal to 6 minus 3 is 3, 3 minus 1 is 2. So I got y to be equal to 2. Finally in the first row, if I write the equation, I will say it is 1 into x is x plus 2y minus 1 into z is z. So w is 0 there, so it is equal to 2. So x plus 2 into 2 is 4, because y is 2, so 2 into 2 is 4, minus z is 1, so 1, which is equal to 2. Therefore x is equal to 2 plus 1 minus 4, 3 minus 4 is minus 1. So these are the 4 solutions for this particular 4 equations which we have got by using Gaussian elimination method. You can use the calculator and put 4 unknowns, and you can solve it in the calculator. You will definitely get these solutions. I hope with these 2 problems, I hope you people are clear with Gaussian elimination method and which are the elements that should be made 0 for Gaussian elimination. Okay, and this is also called as back substitution method, because you find out the last variable solution and you keep on substituting that for the previous one, and finally you end up in getting the first solution. Okay, so that is what back substitution is all about. Okay, I hope you are clear with Gaussian elimination. Thank you.